Well, good afternoon, everyone, and welcome to the Washington Foreign Press Center's briefing on NASA's role in climate science research. My name is Doris Robinson, and I'm the briefing moderator. As a reminder, this briefing is on the record. We will post the transcript and video of the briefing later today at fpc.state.gov. Our distinguished briefer today is Dr. Catherine Calvin, Chief Scientist and Senior Climate Advisor for NASA. Dr. Calvin will start with some opening remarks, and then we will open it up for questions. And with that, over to you, Dr. Calvin.
Thank you so much, Doris. So as Doris mentioned, I am the Chief Scientist and Senior Climate Advisor at NASA. And so what I'd like to do today is to talk a little bit about what NASA is doing with respect to climate science research. But I want to start by giving you some insight into why climate. So if you advance to the next slide. So as many of you may know, we know this from Earth's observations made on and above the Earth's surface, the planet's climate is changing. We're seeing increases in temperature. The animation I'm showing is showing you changes in surface temperature over time. And what we know is that 2021 was tied for the 6th warmest year on record, and collectively the last 8 years have been the warmest since modern record keeping began. It's not just increases in temperature that we're experiencing, we're also seeing other changes in the Earth. Things like declines in Arctic sea ice, increases in sea level, and changes in extreme events like heat waves. So what NASA is doing with respect to climate, we have a broad portfolio of climate research. So we are the US space agency that conducts end-to-end research about our home planet, from observations, models in applied sciences, technology development, and much more. So if you go to the next slide. What I want to do is talk through each of those a little bit more. And so I'm going to start with observations. So this animation is of the current Earth observing fleet. NASA has more than 24 satellites and instruments in orbit, including several on the International Space Station, that are continually looking at the Earth. And we can see things like vegetation, clouds and precipitation, changes in the mass of ice sheets, and much more. We've been making these observations for decades, so we can see not just the state of the Earth today, but also how it's changed over time. Just as a concrete example on that, you'll see in this animation a couple of satellites labeled Landsat. So Landsat satellites, they observe the vegetation, urban areas, snow. They look at land use and land cover, so they can see where we have trees, where there are crops, where there are urban areas. We have just celebrated our 50th anniversary of Landsat, so we have 50 years of observations of the land. And what we can see when we look through that time series and look starting from 1972 through to today is you'll see that there are increases in urban areas, so our cities are getting bigger. We'll see declines in forest area in some parts of the world. And those all have implications for climate, and we can help understand that through our satellite observations. Each of the satellites and instruments we have in orbit is designed to measure something different, so we can see different aspects of the Earth and use them together to get a more complete picture of how the planet has changed over time and provide that information publicly to scientists and to the public. We work with other agencies while we're doing these observations. So many of the missions on this animation are NASA, but we also have collaborations with other partners either within the United States or internationally. So Landsat that I just mentioned is in partnership with USGS, another US government agency. We also have international partners. So if you go to the next slide. One of our upcoming missions is called SWOT, the Surface Water and Ocean Topography Mission. This mission is in partnership with the French Space Agency and includes contributions from the UK and Canadian space agencies. SWOT is targeted for launch on December 5th of this year, so just in a few months. And what SWOT will tell us is more about water on the Earth's surface. So it'll provide information about the amount of water flowing through rivers and lakes. It'll also give us more information about the ocean. And the ocean plays a really important role in climate change. It absorbs heat and carbon dioxide, and so it impacts how much warming we experience and how much we might experience in the future. And SWOT will give us more information about the ocean to help us better understand those processes. So it is targeted for launch in December 5th. We are also working towards planning the next set of Earth observing missions called the Earth System Observatory. These missions are going to be designed to work together to provide a comprehensive understanding of the Earth, everything from surface up through to the atmosphere. And we're working on that now, and they'll be launched by the end of the decade. Our satellite and Earth observing missions, we design them for both to answer science questions, so some of the most important questions about Earth and how it's changed, we can use satellites to help us better understand that. But we also provide that information to help people on the ground respond to changes that they might be experiencing. So we have a disaster team that works with local response agencies and local governments before, during, and after disasters occur to provide near real-time information about what's happening on Earth. So just as an example there, for a wildfire, we can see where fires are burning, we can see burn scars and burn perimeters, we can provide information about emissions associated with fire and the air quality concerns that might emerge from those emissions. And we work to provide that information as near real time as possible. So if you go to the next slide. We also live and work in space. So we have 2 decades of operation on the International Space Station. And part of what happens on the International Space Station is we have Earth observing instruments mounted on the side of it. This particular animation, this is the International Space Station. This is designed for a recent instrument we've installed on the station, our EMIT mission. And this is an instrument that'll help us better understand mineral dust. Mineral dust has an important role in air quality and in local climate. And so this instrument was installed this summer and will be providing information about that using the International Space Station as a mounting platform. And we have several other Earth observing instruments on the International Space Station that provide information about our Earth that we use for climate research and other applications. We also live and work in space, and some of the technologies we develop to live there have benefits here on Earth. So we think about sustainability when we're going to space. We have to bring everything with us, and so some of what we develop can be used for sustainability here on Earth. Just as one concrete example, we grow crops on the International Space Station, and some of the research that NASA's done in growing crops is used here on Earth. So we've done research into LED lighting that's now used in indoor agricultural facilities around the world. There's also a fertilizer that's been developed with input from NASA researchers that directs nutrients to plant roots at the rate that they need it. On the space station, that means we're getting the nutrients to the plant with minimal inputs. Here on Earth, that means less runoff into rivers and lakes. And so we're continually thinking about how what we develop for space has implications here on Earth. In addition to living and working in space, space is one part of our portfolio, but we also do a lot of research on aeronautics. So our aeronautics team has been working with the aviation industry for decades to help understand and reduce energy use and emissions associated with aircraft. So we've been working in a few different areas. One is on technology development, another on sustainable aviation fuels, and another on airline operations. And so we're working towards reducing energy and emissions associated with aircraft. And later this year, we will be testing an all-electric airplane, the X-57. So this will be a test of battery and electric air technologies. And part of what we do with this is we provide that information to industry so that they can use it in their own design and operations. And this is part of a theme at NASA. All that we do, we make available to the public. So we try to provide that information. And so we have a big effort towards open science throughout the agency, not just in aeronautics, not just in climate, but in everything we do. We make information available to the public. For climate, one of the things we're really thinking about is how do we not just get information to the public, but how do we ensure that people know how to use it? So late last year, the administrator announced a concept for the Earth Information Center. And the Earth Information Center is one way for us to get information to people that need it about climate and the Earth. And so this will be rolled out we're in the planning phase now to be rolled out as a phased approach with both an in-person space where we can engage with people and help learn from and teach what we know about climate, as well as a virtual presence so we can provide that information to people when and where they need it. And this will be in collaboration with other federal agencies within the United States. It's part of a broader effort towards open science and open data, again, throughout NASA. So I've been talking a lot about climate. I do serve in a dual role as both a chief scientist and senior climate advisor. And so I did want to highlight some of our other science missions that are upcoming. So if you go to the next slide, or ongoing. This is an image of the Carina Nebula from the James Webb Space Telescope. The James Webb Space Telescope was launched last December. It is now 1 million miles away from Earth and started science operations this summer. So the first science images were released in July, and this is one of those first images. The James Webb Space Telescope allows us to look back in time 13.5 billion years. We can see some of the formation of the early galaxies. We can see solar systems in various stages, from stellar formation, which is what we're seeing here, to other stages of stars. We can also use the James Webb Space Telescope to look at atmospheres of exoplanets, or planets that are orbiting other stars. And we can see the spectra of that, so we can see what the composition is. One of the early images that we released showed that there was water vapor in the exoplanet we were looking at. We've since discovered another planet that has carbon dioxide in its atmosphere, and we're continuing to do that. And like I mentioned before with Open Science, this is a commitment throughout the agency, so that this particular image you can find on our website along with the data behind it, and we're continuing to make this information public and available to scientists around the world. Go to the next slide. We also have a mission DART upcoming. So DART launched last fall, and it has been traveling out to an asteroid. DART is a test of planetary defense. So the mission goal is to try to change the orbit of an asteroid. And so it has been traveling for several months. Its impact is scheduled less than 2 weeks from today. So on September 26th, the spacecraft will impact the asteroid and try to change its orbit. This asteroid is not a threat to Earth, but it's a test of planetary defense. So can we actually change the orbit of the asteroid? And traveling along with DART is a CubeSat contributed by the Italian Space Agency that will provide observations of that impact. So the impact is scheduled for September 26th in the evening Eastern time. So we're looking forward to seeing that. And I will just close now with one last slide. So one of our other major programs and missions ongoing right now is Artemis. And so Artemis 1 launch is scheduled for no earlier than September 27th. Artemis 1 is a test mission. It's going to test the rocket, the SLS, and the Orion spacecraft. It will orbit the moon before returning to Earth. It is an uncrewed test flight. It is the first, though, of a series of increasingly complex missions that will allow us to explore the moon in preparation for missions to Mars. And loaded on board Orion right now is several science payloads. So there's science loaded on the Artemis 1 that will help us better understand radiation and the moon. So there are 10 CubeSats that will be launching along with it. And then there are also payloads in the Orion capsule, things like dosimeters that will help us understand radiation. There are 3 mannequins that will also help understand the radiation environment. And so we're really excited about the science there. The launch is no earlier than September 27th, with more information coming from NASA daily on that as we get closer. And so with that, I will stop my opening remarks and turn it back to Doris for questions.
Thank you, Dr. Calvin, for those remarks. So we will now go to the question and answer portion of the briefing. For journalists in the room, please raise your hand and wait for the microphone. For journalists on Zoom, please hit the raised hand icon at the bottom of the Zoom screen. And when I call on you, please turn on your video. So we will start in the room first. So we will go to our Zoom questioner. So our first questioner, excuse me, is Ragor from Free Eurasia Media. Ra, can you turn on your video?
Do you hear me?
Yes.
Okay, great. Thanks, Dr. Calvin, for this presentation. I have 2 questions. Question 1, in the light of Russia's aggression against Ukraine, what are motives and goals of NASA to cooperate with Russia's space agency, Roscosmos, on climate change research? Can you please provide details of the cooperation in climate change with Russia in the near future? Question 2, Russia threatened to hold and eventually will end cooperation with the Western partners on the International Space Station. Will Russia's pullout from ISS cooperation impact on climate science research? And if yes, how will it impact? Thank you.
Thank you. So we continue to work with all of our international partners for ongoing safe operation of the International Space Station. With respect to climate, the research that NASA produces on climate is available around the world to anyone that needs it, and we have collaborations with several international partners. Just as an example, we have a dashboard that we've put together with the Japanese Space Agency and the European Space Agency to provide information about how the COVID-related pandemic and lockdowns have affected the environment. Just in terms of climate research on the International Space Station, I mentioned earlier the EMIT instrument that was put on the International Space Station this summer. This is a NASA instrument that was launched on a SpaceX commercial resupply, and it was installed on the space station by the Canadian Robotic Arm. And the data that we provide and collect from EMIT will be provided internationally to anyone that wants to use it.
Thank you. Our next questioner is Mushfiqul Faisal from Just News BD, Bangladesh.
Hi, thank you very much for doing this. Thank you, and it's very helpful. I want to ask about, can you hear me?
Yes.
Yeah, okay. I want to ask about Bangladesh. As you know, originally I'm from Bangladesh. Bangladesh is a very vulnerable country for climate change. And what benefit Bangladesh can get from this? As you know, Bangladesh is, many people are suffering for this, the climate change issues. And everybody's talking about adaptation and mitigation, but we need more, in technological support and the funding as well. So what benefit can this Bangladesh can get from this? What is your opinion?
So the research that NASA does is global in scope. So we have information both from our observations and our models that are covering the entire globe. And similarly, our technology development, we develop a lot of technologies here at NASA. The primary goal of a lot of our technology development is about our own space missions and space operation. But one of our mission includes benefits to humanity. So we're continually thinking about how what we develop and use can help people all around the world. And I mentioned some of the crop research. We also have, we have a water processing system on the International Space Station that's been used around the world to provide clean water in communities that don't have it. I also want to mention internationally, we have a partnership with USAID called Servir, where we work with local communities in Asia, Latin America, and Africa to help use satellite observations to tackle real-world problems where they live. And so we're trying to work with local communities about meeting their needs. But all of our information is global and public, and we're working to make it easier to use and so that people have the information and resources that they need.
Thank you. Our next question goes to Jahanzeb Ali with ARY News, Pakistan.
Thank you so much. Thank you so much for doing this. For the past 20 years, Pakistan is ranked among the top 10 most vulnerable countries on the Climate Risk Index, with 10,000 fatalities due to climate-related disaster, financial losses amounting to about $4 billion from 173 extreme weather events. So are you in touch with the Pakistani authorities to help them out to deal with such kind of a big challenge? Thank you.
I had a little bit of a hard time hearing that, but I think the general question is about providing climate information internationally. And so we do work to make our information publicly available and work with that. We have several international partnerships, predominantly with other space agencies. So I've mentioned some of our partners here, Japanese Space Agency, European Space Agency. And those partnerships, some of those are about launching satellite missions. So we have a satellite mission that we've done for 20 years with the German Space Agency that's looking at changes in the massive ice sheets and groundwater storage. So some of those are there. Some of these are about data, providing data externally, but all of the information we collect, we provide globally. And I mentioned earlier, the Earth Information Center is one of the things that we're working on trying to make it easier to use information and provide information to people as they need it.
Great, thank you. I will do one more call for questions in the room. And on Zoom, if you have a question, please hit the raised hand icon at the bottom of the screen. And we'll go right here. And please state your name and your outlet.
Hi, my name is Yuichiro from Kyoto News, Japanese news agency. Do you have a capacity to track the greenhouse gas emission from the space? Because I'm asking this because each country is required to report greenhouse gas emission under the Paris Agreement, and I think we need some system to check and verify each country's inventory. So, or do you have any ability to help and check the each country's report?
Yeah, so there's a lot of different ways that we can look at greenhouse gas emissions. So one of our sister agencies, the Environmental Protection Agency, they actually have inventory information. So they provide bottom-up inventories of how much emissions are. What we can do from satellites is we can observe concentrations of greenhouse gas, and you can infer the emissions from it. And so we have two instruments, or a satellite and an instrument currently in orbit that are looking at carbon dioxide. So the Orbital Carbon Observatory 2 is a satellite that's looking at carbon dioxide, and then there's an instrument on the International Space Station, OCO3, that's also looking at carbon dioxide. There are an increasing number of other missions around the world that provide information like this. So some of the European satellites can provide information. There's a Japanese satellite, GOSAT, that has methane and carbon dioxide information, and there's more planned, both all around the world for this kind of information.
Great. So I don't see any more hands raised. Dr. Calvin, I will turn it to you for any closing remarks.
Well, thank you so much for having me. I'm happy to share what NASA is doing on climate in terms of observations, technology development, and our commitment to open science and making sure that the public has the information that we have.
And I did see one final raised hand from John Kaliba from Czech Radio. John, go ahead with your question.
Can you hear me now, please?
Yes.
Thank you. So I would have two questions, if I can. Can you please talk more about the SWOT mission and its practical benefits you expect it will bring, and then I can ask the second question after.
Sure. So SWOT is it's targeted for launch on December 5th, and it's going to look at water around the Earth's surface, so both fresh and salty water. On freshwater, it's going to give us more information about the amount of water running through rivers and lakes. This has important implications for water scarcity. So we use a lot of water as we're growing crops or producing energy, and knowing how much we have is really important. Right now, what we rely on is a lot of stream gauge information, so we can put an instrument in an individual stream and track the amount of water, or we can use models to fill in where we don't have that stream gauge information. SWOT is going to be able to do this comprehensively and globally, since it is a satellite mission, so we'll be able to see more there. In terms of oceans absorb a lot of carbon dioxide and heat. So how much warmer it gets depends on how much heat goes into the oceans. How much more carbon dioxide is in the atmosphere depends on how much carbon goes into the ocean. And part of that depends on how oceans mix. So how much you take things from the surface down to the deep ocean. And SWOT's going to give us a better understanding of oceans, and that'll help us better understand that process.
Thank you. And if you allow the second question, is more general about the continuity of your work in NASA regarding climate change, because as far as I know, some administrations in the past were denying climate change, even prohibiting to use the term climate change inside of some agencies. And obviously it is possible that this kind of administration will at some point come back again. So how is NASA, how is it even possible to have some continuity in NASA with this environment? Thank you.
So one of the most important missions at NASA is our home planet, and we have been observing the Earth for decades. So a lot of the climate research we've been doing has also continued for decades. And then on the technology development front, our aeronautics team has been working with the aviation industry for decades to reduce emissions from aircraft. And so we have a long continuity of doing this research in the past, and we'll take that going forward into the future.
Okay, thank you.
Great, thank you so much. We'll have one final follow-up question.
I'm sorry. Can you please explain a little bit about the NASA's attitude toward the sustainable use of space and such as avoiding the contamination on Mars or maybe on the moon? And what are you going to do with the unused spacecraft on the ground, moon or Mars surface?
So as an agency, we're committed to finding solutions that minimize environmental impact. And we have a lot of science questions about the moon and Mars that we will be trying to answer through the Artemis program. And through Artemis, we will have, both robotic and human missions to the moon in preparation for missions to Mars. And really thinking, we spend a lot of time thinking about, how do we design those missions in order to gather the scientific input in the best way possible.
And this question is from Kazakhstan.
Yeah, I'm from Kazakhstan. We have biggest space place, Baikonur, and we are renting Baikonur to Russia. But what kind of collaboration might be with Kazakhstan and NASA? You know that because of geopolitical situation, and Russia and NASA have problems, and what kind of problems can have Kazakhstan and the collaboration also? Thank you.
So I can't speak to that directly. What I can say is that NASA does collaborate with a lot of international partners around the world in various ways. I mentioned some of these, partnerships on space missions. We work on the International Space Station. We have a lot of international partners there, and we're continuing to work with those partners for ongoing and safe operation of the International Space Station.
Great. Thank you so much. Well, we will end there. Thank you so much, Dr. Calvin, for taking the time to brief with us today. And thank you to the journalists for participating as well. This concludes today's briefing. Thank you all.